something like that. Right? So on one end you have gamma rays, somewhere here you have X-ray, somewhere you have UV, then you have something like visible spectrum, right? So visible spectrum, on this side it is ultraviolet, on this side it is infrared. Then you have microwaves, then you have radio waves. So all of them are electromagnetic waves, meaning all of them are produced by accelerating charges. Okay. So if you go back to the first thing, the source and production. Okay. The production is what we want to talk about. Okay. So what did we say about the burst theory and all this light? How is this light coming? What causes this light? Excitation of electrons and then falling from higher level to lower level, and that is giving out the energy. So where is the charge accelerating? So we are talking about visible light, right? So this is higher energy and the electron is falling down. So you know electron is nothing but a charged particle, right? So when something is falling down, is it accelerating or not? Right? So when I say falling down, okay, it's not falling down due to gravity, but it's falling down due to the energy level difference. Okay. So that means it is doing some acceleration. So that means it is accelerating of charges. Okay. So it's not like whenever you want to produce waves, it's not like it's always going to be like this to and from moment. So it can be like accelerating this way also. Okay. So whenever something is falling down, you are studying this in means force theory. Okay. So E2 minus E1 is equal to H mu. Okay. So if you go back to visible light spectrum, that's what I put. Excited atoms or excited electrons will cause, so when they fall down to lower energy level, it will be giving out the light photons. Okay. What about the gamma rays? Did we study something about gamma rays somewhere else? What is gamma rays? When is that produced? Radioactive, okay. Where is it produced? How it is produced? What is the reason? Splitting of nucleus, okay. Gamma rays always accompanies alpha and beta. Why does that happen? Energy released during fusion. No, not the correct answer. So when there is alpha or beta going out, right, what happens? The nucleus does not immediately come to a stable nucleus, so it's in an unstable nucleus. So that means, I told you a simple example, when you get into a new house, what happens? Immediately everything is not put in proper place, it takes some time, right? So similarly, the nuclear charge or the protons and neutrons are sitting here and there after a new nucleus has been formed, right? You know that whenever it is emitting alpha and beta, it is forming a new nucleus. When the new nucleus is formed, the protons and neutrons are not the proper places, right? So it's in an unstable situation. So when it comes down to a stable situation, there is an energy level difference. So just like this one, this is for excited electrons. So similarly for excited nucleus, so this is unstable nucleus, this is stable nucleus. So that means, you remember a diagram like this. So when this comes here, it's emitting alpha, beta. But after coming here, it will be emitting gamma. So this is your gamma. Remember this? So I think we studied something like nickel, something. Is that nickel or cobalt 60? CO60 something, 27, 28, I don't remember. I told you at least one thing you have to remember, okay? So maybe we are not given the test for nucleus chapter, that's why it goes up there. So I think this was like cobalt 60 something. Cobalt 60, and this is also. Okay, doesn't matter, we can go back and check it. Okay, so protons are also charged particles. So when they are accelerating and coming down to a lower energy level, it's emitting some rays, and that is your gamma rays. So here it is in visible spectrum. It exactly follows the same logic. E2 minus E1 is equal to H nu. Only thing, this energy level is going to be much different from that energy level. Okay. So this is going to give you light photons, and this is going to give you gamma photons. Okay. So the same logic, E2 minus E1 is equal to H nu. Okay. Have you folks come across X-ray production anywhere? How is X-ray produced? Have you studied something called Coolidge tube? No? Okay. So take it down, it's called Coolidge tube. So what happens is, again, all these details, it's not given by book, it's only for understanding. So you take electrons are made to go at very high speed and hit the anode. Okay. So when they hit the anode, right, it will be producing the X-rays. So why do you think that happens? So again, this is a long theory, but you can assume something like electrons are suddenly stopped with very high speed, right? So when you are stopping, what does that mean? You are accelerating or decelerating, right? So when you decelerate the charge, again you will be producing some electromagnetic waves. Okay. So you will see everywhere the principle is electromagnetic waves are produced by accelerating or decelerating charges. So this is decelerating. So you can say deceleration of electrons in Coolidge tube produces X-ray. Davidson, Jammer. You would send these electrons and it will be going through a nickel crystal. Okay. Whereas here you are making it to hit a target, and then so these particles will become gamma rays. So the energy of this will become gamma rays. Sorry, not gamma rays, X-rays. This is a principle which all your medical facilities are using this principle to produce the X-rays. UV is very close to the visible light spectrum, right? So what can I say? It's going to be very similar to what we are doing here, right? So it's called ionized, using the ionized gases. What do you mean by ionized gases? You are giving some kind of electrical energy to excite the electrons, same like this. So I would say it's pretty much the same principle. So if you read the sentence, inertial electrons in atoms moving from one energy level to lower energy level. That's all. Okay. So this side it is higher frequency or lower frequency? Higher frequency. Higher frequency means you need a difference of E2 minus E1 should be higher or lower? It should be higher, right? So the E2 minus E1 will be higher for this one compared to this one, okay? Because you will be getting a higher frequency. On the other side, infrared, it's like anything hot but not glowing less than 500 degrees Celsius. So these kind of elements which are kind of very hot, right? So they will be emitting infrared rays. So what do you mean by temperature? Somewhere in your 11th standard study, what is the temperature? Temperature is nothing but vibration of atoms and molecules, or the movement of gaseous molecules here and there. That is what is temperature, right? Thermal physics somewhere you must have studied, right? Which means this entire charged particle is kind of moving around, right? And that is causing the infrared rays. So what I am trying to say is, in each one the production is having the same basis, meaning accelerator charges. So accelerator charges produces the EM waves. That's the underlying principle. So accelerator charges produce EM waves in all cases. somewhere we have studied this. How do you think if we study something in your communication systems, maybe we didn't study, but how do you think the radio antennas are working? So it's sending some transmitting signals, right? So it's transmitting the signals. So it is nothing but RLC circuits. So it is having some kind of a oscillation of current. Just give them that brochure and ask them to wait, that's all. Tell them that I have class up to 7:30. So here I have written it as oscillating electric currents. What is current? Current is nothing but electron movement, right? So when the current is kind of oscillating back and forth, have you studied somewhere this LC oscillations, right? So all the antennas will be having some kind of LC oscillations. So it will be producing the. So it's like a very introductory thing. Okay, you're not going to go into the details of all these things. You just have to know how all these things are produced. Okay, they may ask you some 2 mark questions. Or sometimes they may ask you what is the usefulness or uses of gamma rays, what is the use of X-rays, right? So some of them you already know, I'm sure, what is the use of X-ray. You study fractured bones or something, that is one thing. Anything else? In industry they use it to check the correctness of some metals. Okay, so if there is some errors or something, right? So if you have a fault like this, when you do the casting, right? So molten metal, when it's solidifies to become solid, right? Sometimes what will happen is there will be some air lock. So to check those things, they will send some ultrasonic waves or they will send some X-rays to study these things. Okay? So there are a lot of things given in your book. So I'm just going to give you only an introduction here. Okay? So make use of this table and make use of your book properly. Same thing for microwaves, oscillating currents in special vacuum tubes. Okay, so all these things you already have it in your table, so you don't have to write it. So the underlying principle is I am saying that all these things have some kind of charge which is accelerating. Okay, that's what I'm trying to say here. Okay, let's go to the uses. Let's do the easy ones first. What is the use of radio waves? We are seeing radio, TV, all these things are radio waves, right? You are talking on your cell phone, everything is radio waves. Okay. So radio, TV, communication, all these things. Have you seen this? Near the airports, they have airport tower. From there, they will be communicating with the pilots in the plane, right? So it's called the airport tower. So they pretty much use microwaves. Okay, so microwave is something like a smaller than this one, right? Remember, faster rather than faster, it is something like line of sight. Okay, compared to radio waves, all these things are having the same speed. Okay, c is equal to 3 into 10 power 8. Okay, so all of them are having the same speed. Okay. So to answer your question, it's something called line of sight in communication systems we studied. So what is line of sight? If you have some kind of a block, a wall or something, you cannot talk with the other, you cannot communicate, right? So it has to go in a straight line. Okay, so the tower is like this. So from the plane, let's say that's a plane. So it will be like a line of sight, which means it's one single straight line. Okay, so that we can communicate. If there is some kind of hindrance, then you cannot communicate. Clouds, I think it can pass.
So what about space stations, like from Earth to the moon or something?
Space stations, we are communicating with satellite. So that is also we studied in the communication systems, right? So it's called the space waves. Right? So Microwaves and space waves are almost the same. So you are sending the, so from the antenna, so it will be coming at radio waves. So you have the satellite somewhere here, let's say it's something like this. So it goes like this and then comes back to the earth. So the reason why I started this was radar long distance wireless communication via satellites. So radar means, what is radar? They will keep on sending some kind of a waves, and then when it is kind of reflected back from the plane, they can identify where the plane is. Okay, so have you seen in the movies, there will be some kind of a graph, like a circular graph like this, and then the waves will be kind of going around like this. Have you seen that? So that's what. So if the plane is here, it will detect it, which means it will come back. So once it comes back, you can say, okay, the plane is located at that particular point. Okay, the computerized thing, it can show you where it is. That's how they control the air traffic actually, right? So if two planes are at the same level, they have to immediately inform the pilots to go at a different level, right? So they are controlling all these things from the ground station. Okay, what is the use of visible light? Any uses, good uses? Do we have any use at all? To see, right? Anything else? Photosynthesis, right? So the plants make their food from photosynthesis. Okay, UV treated food, have you seen that? Your food items, sometimes it will say UV treated water, UV treated food, right? So why do they do that? To kill the germs, right? So that is one good use for UV rays. Okay. Detect invisible writing. Okay, so I think you have some kind of, so if you want to send some kind of a message where you don't want other countries to see it or something, but I don't think, probably these are all some older techniques, probably they don't use it now. Okay. X-ray, we already talked about it, right? Medical diagnosis, structure of atomic crystals. Why structure of atomic crystals? What is the size of X-ray? 10 power minus 10 meters. What is the size of atom? Atom is also somewhere that order. So you can use only X-rays. You cannot use these things. You cannot use this. You have to use only this one to study the atoms. Okay. Information on atomic nuclei, I don't think they explained it better. But basically this is coming from nucleus, right? So this is atomic size, this is nucleus size, right? So this is basically giving some information about the nucleus. Okay, what else we didn't see here? Infrared, right? So what is the use of infrared? TV remotes, very good. Anything else? So somewhere I have shown you this infrared light, right? So that's the infrared light. So this is used for some medical purposes, right? And also for to see in haze and fog. So have you seen some movies where they use like infrared cameras, infrared visibility, something like that, the night vision. So for that they use infrared. Okay. And even there is something called what is that?
Thermostat camera.
Thermal imaging. We had that. So there was some movie, I forgot that, some English movie where the alien he cannot be seen by the usual predator, yeah. So they will use the thermal imaging, right? So if there is some kind of thermal activity in their body, using the thermal imaging they can detect the person where he is, okay? Even though you cannot see it by the visible light, okay? That is thermal imaging. So those things are used by infrared. What is this greenhouse? To keep plants warm in greenhouse. CO2. Okay. Cold regions, cold countries, they use greenhouse, right? To keep the plants inside, right? If you keep it outside, the plants will not survive. So you need some kind of a good environment or good temperature so that the plants can survive, right? So the greenhouse, what happens is, it's more like a glass house, so the entire thing is kept inside a glass. So the sun's rays is kind of high frequency and it enters into the glass. But then once it falls on some objects, right, when it reflects back, the energy will be less. When the energy is less, frequency will be less, right? So when the frequency is less, you can show it like this, so like a higher frequency, right? So because of this low intensity or low energy, right, it was able to enter into the glass, but it's not able to get out of the glass. So that means all these things will be returned back and keep the glass house warm. That's the principle. Okay. So this is what is called greenhouse. What is greenhouse effect? This is greenhouse, but what is greenhouse effect? The same thing happens in an atmospheric, big atmospheric level. So they say that sun's rays enter into the atmosphere, but then after hitting the earth, right, so it's not able to go out, which means the temperature keeps increasing. Okay. And what is the problem with that? Global warming, polar ices will be melting down, okay, which means the coastal cities will be flooded. Okay. So I heard a news somewhere, Mauritius. Mauritius is an extremely small, tiny island, right? So almost going down, right? So they don't have enough lands at all. So the Mauritius government itself is buying a lot of lands in India so that they can, come over here. The island goes down. Maldives, I'm not sure. Mauritius, I think. Can double check. Okay, go to the next one, source. So you know that gamma rays are coming from radioactive matter, right? X-ray Coolidge tube, UV rays, mercury lamp, visible light. One example is sun. All these things are visible light, okay? IR, all these things are hot bodies, right? So from these things you can produce infrared rays. Microwave, you have seen microwave ovens for cooking purposes. What is the principle behind microwave oven? What is it?
Heats up the water.
Vibration of? It vibrates with the natural frequency of the water. It matches, which means resonance happens, which means it will heat up the food particles which has water in it. Okay. The porcelain container, it will not heat up at all. Right? Why? Because it doesn't have any water molecules. Okay. TV, radio, antennas for radio wave. Okay. So I try to give you a simple summary, but that doesn't mean this is sufficient. So I recommend you to go through the book. Okay. So if you have your books, go to page number, let's see. So go to page number 281 or take it down in your notebook. Page 281 to 283. You're supposed to go through it. Okay. So I'm just caring. Okay. Nothing much to understand. Just go through it. Whatever you can remember is good for you. Okay. They may ask you give 2 uses of UV rays, 2 uses of infrared rays, 2 uses of gamma rays. You have to try to remember at least 2 or 3 uses for each one of them. Okay. Or they may ask you how gamma ray is produced, how X-ray is produced. So you should know the production. Okay. So you should use this keywords: oscillating currents, Coolidge tube, okay, X-rays, deceleration of electrons in Coolidge tube. Okay. If something is missing in the table, make sure you take it down. So how is infrared produced? Hot bodies, right? Hot bodies are accelerating. So it has got some accelerating atoms and molecules which are having some charges in it. Okay, so that is one part of it. Body the channel. Okay. He's thinking, it's making us of his brain. Wait, what is the problem with that? See, only people who have questioned a lot of things, only who have, clear thinking, they have become good scientists. Okay. All the others will just follow whatever has been, done by others. So if you want to become a good scientist, you have to keep questioning. Why not this, why not this? Okay. Then you can invent something new. Okay, that was one part. I wanted to do some more derivations and rules. So let us talk about something called Hertz experiment. Okay, so this part I expect you to read your textbook and also the argument. So make sure you are thorough with all these things. Okay, very often they will ask you 2 or 3 months. This entire chapter is like somewhat compared to other chapters, it's low weightage. It's only 4 months. So make sure you are studying this part properly. Whether you study the previous part or not, this you have to study properly. The previous part is little bit, what do you call electromagnetic theory. It's little bit high level. So you'll be studying again in your college. You go to BSc.